Today we will be dealing with periodic table. In this we will first study about the definition of periodic table. Now what is periodic table? It is nothing but a table giving the arrangement of all known elements according to their properties so that elements with similar properties fall within the same vertical column and same groups or same periods. So in easy language if we say it is a table giving information about the arrangement of all known elements according to their properties in groups and columns, groups and periods. Horizontal is the periods and the vertical is the groups. There is nothing but a systematic arrangement of elements so that the elements with similar properties fall in the same place or almost in the same position, in the same vertical column or the same horizontal row. So now we have a modern periodic table. Earlier the elements were not arranged like this. Earlier there were some early attempts to classify the such well constructed periodic table was not there earlier. So we will discuss some of the early attempts. Those are metals and non-metals. This is the first classification. It's a very broad classification, not much information we were getting from it. First of all, it was given by Lavoisier. It was given in the year 1803. John John Dalton published a table of relative atomic weights, which form the basis of classification. After this, then came the classification by Dauverigny. This classification was given in the form of triads. Triads means the elements were arranged in a group of 3 elements, in which the atomic mass of the middle element, such as B, was the arithmetic mean of the atomic masses of A and C. So if we see, practically we understand it with the help of example of lithium, sodium and potassium. This was one of the triads which formed. The atomic mass of lithium was 7, potassium 39, sodium 23. So how this is applicable to the triad, we'll see. We will add the atomic mass of A and C, lithium and potassium, and divide by 2, so it will give 23, which is the nothing but the atomic mass of sodium. So this classification was given in 1817 by Dauverigny, was a German chemist. He arranged the elements with similar properties in groups of 3. Similar elements in groups of 3, which were called as triads. Some more examples of triads are S, Se and Te. Their relative atomic mass are 32, 79 and 128. So if we calculate the arithmetic mean of 32 and 128 divided by 2, it will give 79, which is the atomic mass of middle element, that is Se. Sulfur 32 and Te is 128. Other example of a triad is Cl, Br and I. Cl is having an atomic mass of 35.5. Br is having an atomic mass of 80 and iodine is having an atomic mass of 127. So if you apply this, then 127 plus 35.5 divided by 2, this is giving 81.25, which is approximately the atomic mass of the middle element. This is bromine. Next example of triad is CaSr and Ba. With atomic masses 40, 88 and 137. So applying this, 40 plus 137 upon 2, which is giving 88.5, which is roughly about 88, which is the atomic mass of the middle element. But there were some limitations. Which were attached to this. Those were, that is, the atomic masses of, he made many triads in which in some of the triads the atomic masses of some of the elements were same. Example is atomic masses of some elements were same. Example is iron, cobalt and nickel. They are having almost similar atomic masses. Then also he made their triad. He could not explain why, but today we know the reason. Because these were having the same properties that were arranged in the same. He tried to make a triad, but this arithmetic mean thing was entirely different. It was not fit to that. And the other limitation is it was restricted to few elements only. So it was not widespread. It cannot be applied to all the elements. So restricted to few elements only. So after this, try to arrange the elements. The arrangement of elements, the trial for the arrangement of elements was going on, and a new work came in the name of Newland law of octaves. Octaves, we know they are the musical octave. We know that there are some musical octaves like sa re ga ma pa. So this law is related to that only. Like in sa re ga ma pa da ni sa, there is repetition of sa after the seventh word. He arranged the elements in increasing atomic mass and he saw that there was a repetition of the properties after the seventh element. So we will start with, in the year he gave this in 1866. It was given by, as the name suggests, John Newland. He was an English chemist. He was an English chemist. He proposed a new system of grouping elements. He tried to correlate the properties of elements with the atomic masses. Correlated properties with their atomic masses. He started with the elements having lowest atomic mass and arranged them in increasing order. Arrange elements in order of increasing atomic masses. We started with the element having the lowest atomic mass, hydrogen, ended at thorium. So we started with hydrogen, ended at thorium, and thorium is having atomic number of 56. We observed that every eighth element has a property similar to that of the first. We call this relation as law of octaves. So if we try to draw it, we'll look at it like this. But there were some limitations also. After so there were some limitations also, as those are the law of vectors was found to be applicable only up to calcium. Law of octaves was found applicable only up to calcium. So position of hydrogen along with fluorine and chlorine was not justified. We know that that is alkaline, that is gas, that is fluorine, chlorine are halogens. Position of hydrogen with F and Cl, because they are having entirely different properties. Hydrogen loses the electron is electropositive, F and Cl gains electron is electronegative. So with fluorine and chlorine, so we will take it as limitation. Neuron place two elements in the same slot to fit in the group elements. Sometimes you put the two elements together just to fit in the series group or table he made. Like example, cobalt and nickel, as we saw, he put together just to maintain the continuation of similarity in properties. He did so. Soon it was realized, thus it was realized that the Newton law of octaves worked well with lighter elements, not with heavier elements. Applicable only up to sodium. Next came the Lothar-Meier's curve. Lothar-Meier's classification. In 1869, Lothar-Meyer studied the physical properties like volume, melting point, boiling point. Some of the physical properties like volume, melting point, boiling point. The plotted a graph between the atomic masses against the respective atomic volumes for a number of elements. Example, plotted atomic volume on y-axis and atomic masses on x-axis. Atomic volume on y-axis. There is a some pattern he observed, the graph roughly looked like this. The pattern which he observed was that elements with similar properties occupied the similar position in his graph. Example, alkali metals like sodium, potassium, lithium, rhodium, cesium, they are having large atomic volumes. Thus they occupied the crest. Crest means these positions. While the transition metals occupied the troughs. Troughs means these. Transition metals occupied the troughs. The halogens they occupied the ascending position. Ascending position means around here. H, FCl, all over occupied the position here. There were some drawbacks of this for the classification given by Lothermeyer. This was, as we know, that is not a convenient way to classify elements. We cannot remember the exact position of the elements easily. Also, it was a hypothetical classification. It was difficult to remember. The position of different elements. Different elements.